In this video, we are going to look at an example where we are going to find an equation of a tangent line at a given point, but the function that we are going to look at is going to require us to use implicit differentiation, or at least we're going to use implicit differentiation. So let's look at our function. So here we have x times cosine of y is equal to 1. We want to know what is the equation of the tangent line at the point 2 comma pi over 3. So in order to find an equation of a line, we need a point and we need a slope. So we have a point, 2 comma pi over 3, so let's figure out the slope. So our slope, we need to know what is the derivative. Here we have x times cosine of y is equal to 1. So we are going to find that derivative implicitly. So we have a product rule that's going to happen here. So the derivative of the first derivative of x is 1 times the second plus the first times the derivative of the second. Derivative of cosine of y is going to require a chain rule. Derivative of cosine is negative sine. The inside stays the same, and then we will multiply by the derivative of the inside, dy dx. Now don't forget to also take the derivative of the right-hand side. So derivative of 1 is 0. That's one of the more common mistakes. People forget to take derivatives of the right-hand side, in particular when it's a constant. When it has variable stuff, they tend to remember it better, but when it's a constant, that gets overlooked quite frequently. All right, we're going to solve for dy dx, but let's do something a little bit different than what maybe we've done in the past. So we could solve this for dy dx all by itself, and then plug in our values of x and y. And that's perfectly fine, perfectly legitimate. You can do that if you would like. Another option, though, is we can plug in our values of x and y first, and then solve for dy dx. So when x is 2 and y is pi over 3, we have cosine of pi over 3 plus, I suppose it will be minus 2 sine of pi over 3 dy dx is equal to 0. Cosine of pi over 3, that is 1/2. Sine of pi over 3 is root 3 over 2. So I'm going to subtract the 1/2 from both sides. And then divide both sides by that negative square root 3. So dy dx is 1 over 2 root 3, or root 3 over 6. Great. Are we done? No, we are not done. Right? This is just the slope, right? So this is finding the slope of the line. We need the entire equation of the tangent line. So if that's the slope, then our equation y minus the y value of the point, so y minus pi over 3, is equal to our slope, root 3 over 6, times x minus the x value. And so that is point slope form. We have a point here, and we have a slope here. And so it's y minus the y value of the point is equal to our slope times x minus the x value of the point. If we wanted this in slope-intercept form, we can just then solve this, add the pi over 3 to both sides, and distribute out. root 3 over 6x minus root 3 over 3 plus pi over 3. So you have the equation of a line in slope-intercept form, or if you want it in point-slope form, that's also perfectly acceptable. All right, in our next video, we are going to look at another example that's going to require us to use implicit differentiation. So I will see you there.